Okay, ladies and gentlemen, today we're going to start with something that you've probably seen in Im2 and been practicing for a little bit. So if you look at this first section here, what I want you to do is go ahead and write down in your notes, what do you notice about these diamond patterns? I know most of you have probably seen them already and probably know what they mean, how you kind of puzzle them together. But go ahead and in your own words, I want you to write down what you know about them. And if you don't know anything, write that down. I say, I don't know what the heck is going on, because this is what we're going to cover today. And I just want to make sure that we get this going, because this is going to be a big part of factoring today. Okay, something that we're going to have to be very good at. So I'll give you time to do that. So if you want to pause the video and go ahead and write in what you know about these diamond patterns in the first section, A, B, C, and D, go ahead and write that down now. Okay, so we're going to start in example E. And our job here is to list all the factor pairs and then complete the diamond problem. So I'm going to teach you how to do this if you've never seen it. If you've seen it before, this is going to be a nice review. So what I'm going to do is kind of explain what the diamond pattern is all about. So this top number in example E here, 16. 16 is a number that we want to use to find our factor pairs. So what we're trying to figure out is what multiplies to 16. So we want to know of all the things that we can figure out, or all the factor pairs we can figure out to multiply to 16. So we're going to go ahead and list all the factor pairs of 16. So let's go ahead and start listing them. Okay, so what we have listed is all the factor pairs of 16. We have 16 times 1, 18 times 2, and 4 times 4. What you also have to understand is that these are the positive factor pairs. But 16 also has negative factor pairs. So I'm going to list all the negative factor pairs, because remember, we want to find two numbers that multiply to positive 16. So this is the first list, but we also have a second list. And that list I'm going to write below. So it's going to be basically the same problem, 16 times 1, but now it's going to be negative 16 times negative 1, and then negative 8 times negative 2, and I'm running out of room here, but it's going to be negative 4 times negative 4. So these bottom three pairs will also, if you multiply together, these will also give you when you multiply together, they will also give you 16. So this top number here. Now, of all the pairs we've listed, we want to figure out, including their signs, what pairs of numbers will actually add up to the bottom number, 10. So we go through all these pairs, and we want to see which ones will add up to positive 10. So as you go down our list of 16 times 1, 8 times 2, 4 times 4, 16 times negative 16 times negative 1, and so on, the only pair that adds up to 10 is going to be 8 times 2. I call this the magic pair. Okay? So once you find that pair, that's how we fill in the other two parts of our diamond. So we put, it doesn't matter where they go, but we put positive 8 here and positive 2 there. And that's how we fill out the rest of our diamond. Go ahead and pause the video and go try example F and G. Okay, so for example F, our factor pairs are as follows. So we have 6 factor pairs here. As you can see, a lot of students' common mistake is they forget that you can have 2 negatives to make and multiply into a positive. So don't forget that second list when you're doing this. So of all these 6 pairs, which one will add up to -9? So if you look, the pairs that add up to -9 of this list is going to be 6 times -3, or -6 times -3. So that's where we put our answer into our diamond. And it's that simple. Okay, last example, I'm going to go ahead and list all the factor pairs of -24 and fill out the diamond after. So as you look at the factor pairs of -24, we actually have what looks like 2 sets. In this first set here, we have -1 times 24, but in this second set, we have -4 times +1. So both of these sets, when multiplied together, will give you a -24, and that's what we're looking for. So as these numbers get bigger and bigger, you're going to end up with more and more factor pairs, especially when this number here is negative. You almost have 2 sets of opposite signs, if that makes any sense, okay? So out of all these pairs, we're trying to find the one that adds up to 10, +10. So signs are very important. So looking at all these, which group would add up to +10? And the answer to that would be this guy right here. I'm going to change the color so we can kind of get a better view. -2 and +12. If you throw that in, that's going to give you 10. Okay, so in essence, what we're trying to do for these diamonds is figure out what multiplies to the top number. So we want to multiply to top number, but add to bottom number. Okay, and that's what we're doing with these diamond pairs. So hopefully this was a good review. If you've never seen this before, it's kind of just putting a mathematical puzzle together. Okay, so again, we want to multiply to the top number, but also add to the bottom number. And whatever 2 numbers do that, that is what I call a magic pair. All right, let's begin. One of the methods that we have to understand in factoring is called GCF, which stands for greatest common factor. So when we are going to start doing the process of factoring, this is probably the method we want to start with. When we get into Im2, I'm going to teach you about 3 different methods of factoring. This is just going to be the first one. So let's start with GCF. The definition of GCF, it's the greatest number and or variable that can divide out of every term in the expression. Okay, so in essence, what we're trying to figure out is what's the biggest number or variable that can divide everything in our problem. So if we look at example H, okay, we have a couple things that we need to make sure we understand before we go ahead and do a GCF. This should be reviewed, but I just want to make sure we touch base on it. This problem H, this is called a polynomial. Okay, so a polynomial is made up of numbers, variables, adding, subtracting signs, and so forth. Another important part of a polynomial is what we call a term. A term in a polynomial are these little suckers right here. 10x squared is a term, and 15x is a term. Terms are usually separated by plus or minus signs in a polynomial. So what we're going to do, now that we know some vocabulary here, we want to figure out what factors, or what's the biggest number that can divide out each term. Okay? So when we do that, if we look at example H, let me just erase this really quick. If we look at example 8, we are trying to figure out what's the biggest number that can divide 10 and 15. So again, what's the biggest number that can divide 10 and 15? So the biggest number that can divide 10, that also can divide 15, you should be thinking 5. And again, this is kind of where our divisibility rules that we talked about yesterday or the other day come in handy. So the biggest number that can divide 10 and also 15 is 5. So the next thing we want to look at is we also need to figure out, can we divide out variables? So if we look at these variables here, we have x squared and we have x. So the rule I have on that is very simple. If all your numbers or your terms in your problem have a variable or they have a common variable, we want to pick the lowest powered as part of our GCF. For example, in this problem here, the first term has an x squared, the second term has an x. Since they both have the same variable, we are going to include a variable in our GCF, and all we have to do is figure out which variable has the lowest power, x squared or x. Since x is the lowest powered, he would be part of our GCF. So if you do example H here, the correct answer would be B. 5x is the biggest number and variable that can divide out our polynomial of 10x squared minus 15x. Okay, next example. I'm going to move a little faster here. So the same question. What's the biggest number that can divide 12 and divide 8? Again, we're trying to find the biggest number. Sometimes we make the mistake and just find any number. We want the largest number that can divide 12 and also divide 8. A common mistake on this problem is people will say 2 is the biggest number, or 2 can divide 12 and 8, which is correct, but it's not the biggest number. Okay? The correct answer here would be 4. 4 is the biggest number that can divide 12 and also 8. Now we move on to the variables. Both terms, do they have a common variable? And the answer is yes, they both have y. One has y to the third, the first term has y to the third, the second term has 8. And second term has just a single y. So since they both have a common variable together, we pick the lower powered one, which would be 4y or y. So our answer to the GCF here would be 4y. Okay, so the example H and I above were the skill you need in order to use GCF factoring, or greatest common factoring. So we actually did not complete the problem. We're going to actually do a full-on factoring method in example J. So we're going to find the GCF, and then we're going to factor it out. In order to do that, you want to make sure you understand this concept here. When we are factoring out a GCF, you are dividing it out from every term. Once you divide it out, we then put it into this format. Okay, so I'm going to do example J and show you how this works. So just like before, we're looking at each term, 8x and 6, and we're trying to decide what's the biggest number that divides 8 that also can divide 6. So when we do that, the GCF, greatest common factor, is going to have a 2. 2 is the biggest number that can divide 8 and also divide 6. Okay? Now looking at the terms, we can't forget the variables. The first term has an x, but the second term does not, which means we do not have a variable GCF. So our GCF is just 2. So now that we know our GCF, we want to put it in this format. Okay? Our GCF will be in front, and then we're going to put some stuff in parentheses, because we basically want to turn our problem into a multiplication problem. So how do I figure out to put stuff in parentheses? What do I put in the parentheses? It's pretty easy if you can divide. Okay? Well, all we're simply going to do is take our GCF and we are going to divide it from our original polynomial. So I'm going to divide 8 divided by 2, and that answer is going to go here. So 8 divided by 2 is 4, and then since nothing is dividing the x, we bring in the x. And then I'll go 6 divided by 2, and that is positive 3, so we put positive 3, and we have now factored using GCF. And that would be your final factor problem. So keep in mind, our goal when we are factoring is simply this. We want to turn our problem back into multiplication. Okay? All right, so that's basically what we're doing factors. So we had a problem, our original problem, 8x plus 6, and we simply turned it into multiplication here. It's now 2 times 4x plus 3. All right, go ahead and I want you to try to do the following examples, K, L, M, N, and O, and see if you can get those going. So make sure you pause the video before you go forward.